Hey guys, it's PrintStart 3D. Welcome back to testing the Anycubic Kobra S1 combo. And we've already printed a couple things, and you guys have left a bunch of replies and comments and questions and concerns. We've printed the MacGyver Dragon in multicolor. It turned out pretty good. We printed a Benchy. We're going to be running a bunch of tolerance test prints. Let's go over to the slicer and see what we're working with. Alright, so on the slicer, what we got today is this right here. This is from Control V, and it's on Thingiverse under Test Your 3D Printer V3. And there's a ton of tests on this single model here. We got it in the slicer. We're going to do the standard 0.2 millimeter layer height with the Anycubic PLA as well. We got that loaded up in orange. And you'll notice right here, if I go to the prepare section and I can actually look at the model itself, you'll notice that these walls here don't actually show up on the sliced model. And that's because they're really thin walls. And to fix that, or to partially fix that, we're going to go over to the strength tab right here and click detect thin walls, which it detects thin walls which cannot contain two lines and uses a single line to print. It may not print well because it's not a closed loop and it's just a line. So we're going to check that, click slice, and you'll notice now we have two more little sections that are able to print, but there's one more left. So what do we do about that? Well, we have a 0.4 millimeter nozzle, and that 0.4 millimeter nozzle is just not small enough to print something that thin, and I can actually prove it to you. So go into the printer settings, go to extruder, and change the nozzle diameter to 0.2 millimeter nozzle. Close that, reslice, and you'll notice now we can print all of them. But we don't have a 0.2 millimeter nozzle, so that's not going to work. So we're going to just go to 0.4 millimeter. That's what we have installed, and that will be the limitations of the 0.4 millimeter nozzle. And that's not just on the Kobra S1. That'll be with any printer you choose to do this test on. That's just the limitations of the 0.4 millimeter nozzle. So let's see what kind of tests we got here. We have a 4 millimeter hole. We have the actual height of this entire base plate, which is 1.1 millimeters. We have a warping test, which is this circular feature right here, which will also show us the surface finish as well. We have a spike right there, which is just a tall spire shape that gets smaller towards the top. We have a bunch of overhangs that range from 25 degrees all the way to 70-degree overhang. We got a little pyramid shape object, which is right here, which we'll be printing. We have a rounded print, which has like a rounded divot on the inside. You can see it's kind of rounded off. It kind of looks like a little bowl shape. And then we got the nut, which is a M4 nut shape. We have a star for sharp edges. We have the text cutout, Control V text. We have hole sizes by 3, 4, and 5 millimeters. We have minimum distance plus wall. So these tiny little slots are from 0.1 millimeter all the way to 0.7 millimeter. So it's going to be really difficult to print the 0.1 millimeter on a 0.4 millimeter nozzle, but we'll try it out. We have a rounded half sphere section as well. We have the wave section as well for rounded sections. This is going to be these little wavy parts right there. And then we got some bridges. We have 2, 4, 8, and 16 millimeter bridges, as well as 3D printed font on top of the base plate. So that's going to be a 2, 4, 8, and 16, indicating the bridge length. We also have some layer height tests. So there's 1 layer, 2, 3, 4, and 5 layers, which will also test the printer's step ability as well. So that is the Control V test. We're going to run that guy, and let's see how long it'll take actually. So we're going to go here, click line type. It's only going to take 29 minutes. It's going to take 33 minutes total to prepare everything. As you can see here, you have model print time, which is the actual time it'll be printing, and then total time is the setup time, like preheat time and all that leveling and resonance testing and all that stuff. So it's going to take 33 minutes and 52 seconds. It's going to use 7.25 grams of filament, and it's going to cost only 14 cents in material. And if you actually want to get a more accurate cost, go into your PLA or your filament settings here and go down to price and say this filament was $30. Just change it to $30 and then slice it again. And now the cost is 22 cents versus 14 cents. So that's how you change the price of filament if you want accurate cost, if you're actually selling these prints, which I would never sell a tolerance test print, but you could. Here's all the settings I'm at right now. On the cooling settings, we're just gonna keep everything default except for detect thin walls, and we also turned off the brim because the brim will interfere with some of this stuff here. We're not gonna want the brim on that. It's just a test print. So we got this guy ready to go. We're gonna remote print this guy. Click remote print and print while drying. I also noticed a little bug in this thing. It doesn't let you change the temperature of the AC unit in the slicer. Like whenever I go to type something out, it doesn't let me change it. It might be actually inside of this somewhere. That 35C might be somewhere in here, but we can always change it on the printer. So let's remote print and see how it does. We're going to do bed leveling, resonance compensation, AI detection, and we're going to skip the time lapse, but I do want to do a print with the time lapse feature soon. Let's start it up. You can see it loads pretty quick, and now it's going to switch to the workbench. There we go. Let's go to the printer and see what's going on. All right, so we're at the printer right now, and it's preparing the file I just uploaded. So right now it's doing its little preheating and all that. We're gonna let it go and we'll come back once it starts printing. I made a mistake. I started the print as the white filament. I want the orange filament. That was an accident. So to change the color of the filament on a single color print, just click this button right here and you can select what roll of filament you want to use and print while drying and start print. We're done printing the Control V test. This one took 33 minutes and we're gonna check out the results here. It comes off pretty good. Alright guys, here is the Control V test in my hands. Let's take a look at the overhangs real quick. I'm actually really impressed with those overhangs. You can see it didn't fail on any of the overhangs, and especially this far one right there. That's a pretty solid overhang, I would say. And here we have the round section, and you can see it's a little bit stringy, guys. The filament is still a bit stringy. I have been drying it in the filament dryer, but it's just really humid where I live, so you can see the surface quality is pretty decent on there. I'm actually gonna zoom in a little bit. So there is the surface quality, and this little section is just like a circle overhang. Did pretty good. It does have some little holes on the right side of the circle, which could be just how fast it was going, and maybe the temperature needed to be adjusted. And here's the first few, here's the layers, the 1 layer, 2 layer, 3, 4, 5, and the first one looks good, second one looks good, third one looks a little bit separated, but that could be fixed in the slicer settings. These look pretty good. The third one though is a little bit separated on the top layers, but I don't see that to be the case with the fourth and the fifth one here, so I'm not really sure why that happened. Here's the bridging, Here's a 2mm, 4mm, 8mm, and 16mm bridge. You can see the 2 is good, 4 is good, 8 is good. 16 gets a little bit stringy there. You can see the string drooping down a little bit. That's still pretty decent. And here are these super thin walls. You could see that there is a string in between these 3 right here. That could be the retraction settings, and the temperature settings as well could be a little bit better. Got the wavy section, looks pretty nice. The little half sphere looks pretty decent. Once again, a little bit stringy. And then you come over to this section with this little comb shape here. And it goes down to all the way to 0.1mm. So that's really tight tolerances. I think it did pretty decent. It did lift up a tiny bit. As you can see, those 2 are lifted up right there. They were lifting off the build plate a little bit. These 3 right there are pretty good on the build plate, but these last 3 were a little hard. And you can see the circles are pretty good. They look circular, and I'll measure them with calipers as well. Here's the Control V text. It's not the best, honestly. The text could be better. This text right there is pretty decent, but the actual text on this part is not very good. It's all about speed, temperature settings, and stuff like that, so you can always adjust it. There's the star shape. It looks pretty good. Not the sharpest, but we're still talking about a 0.4mm nozzle printing that small. That's pretty decent. The hex shape is not quite how I would like it, but we can measure that and we'll see if it lines up. Here's the little bowl shape. That looks perfectly fine to me. The seam, however, is a bit bulgy. You can see there's a bulge on the right side right there. But the inside looks pretty good. Pyramid shape looks good. No complaints about that. Maybe the temperature was off. And the spire is not as tall as it should be. And I think what happened was between the spire and this round piece, it got messed up. I wasn't really watching it, and I was only watching the first layer, but what I think happened was the very tip of the spire actually, it seems like, is over here on the edges of this circular part. That's why the circular part has these like little things on them. Like this one especially right here, I think that's part of the spire actually. But this one at the very tippy top, I think that's just part of the print itself. The bottom looks good, being on a textured PEI build plate. It looks pretty good, guys. Honestly, like, for a budget Core XY machine with 0 tuning, and I haven't dialed in the temperature, anything like that, my filament's still wet, I would say I would probably give this probably like a 7 or 8 out of 10, possibly maybe a 7 out of 10 in terms of quality. It could be better, like the text could be better, the spire could be better, the retraction could be better right there, and that's kind of all of my bad points about this print, but honestly it's pretty good. So let's actually grab some calipers and compare this to the picture that I showed you guys earlier on Thingiverse. Let's now compare the measurements from this photo and let's see if it's accurate or not. So we got the calipers, we're gonna zero them out, and I'm gonna check these holes right here. So this one should be 5mm, this one 4, and this one should be 3. So let's see what we got. So that one's definitely smaller. So let's check this hole, 4mm hole. Okay, that's pretty decent actually. So I'm going around the hole, 3.8, and then, so that's the 4mm hole, it's 4.02, that's pretty good. The bridge is supposed to be 16mm long, I'm getting 15.81, this one's supposed to be 8, I'm getting, let's say 7.78. So this little wall, so this should be 0.7mm right here. We're getting 0.89. Let's see what else I can try. Nut is 7mm. So this one is supposed to be, so this one's supposed to be 1.1, and it's 1.1, about maybe a little bit, maybe just a tad thicker, but it seems to be 1.1, 1.1. So that's pretty good. The only thing that kind of concerns me these hole sizes. I'm getting 4.8 for the 5mm hole. I'm getting 3.75 for the 4mm hole, and for this one I'm getting 2.6, 2.7. So yeah, that's the little measurements on there. Let me know what you guys think. We're gonna run a few more calibration prints. Now let's do the 20 by 20 cube and see what happens. All right, so here we have the 20mm cube, and I'm gonna redo this because I wasn't recording. But to make a 20 by 20 by 20 cube, right click, add primitive, and press on cube, and that'll spit out a cube shape into your slicer that you can just slice up and print. But we want it 20 by 20, so go to the scale. You can press S as well, scale, and you'll see uniform scale. Make sure that's checked, and under the size you can set the dimensions of your object. And for this cube, it's obviously a cube, so all the sides are the same, so uniform scale is easy, and we can set it to 20. There we go, that's a 20 by 20 cube, and let's slice it. And we have these white lines. You're probably like, what is that white line right there? Well, those white lines is called the seam, and a seam in 3D printing is where the layer starts. That is where the print head will start extruding filament at the beginning of the layer, and you can see it right there. In this case, you see the print head swoop around, and then it drops the seam right there. So yeah, a seam is pretty much the start and the end of your line path in the outer wall, and they are visible in your print. And if you have seams, a lot of people are new to printing and they see these little dots everywhere on their print. It's because that's the seam, that's where the print head starts and stops, and you can actually adjust it so the seam is less visible. But on this cube, there's only 4 spots to put the seam, and that's at each corner of the cube. But on a round object, you would just position the seam into the rear so you can't really see it. If you're going for looks and quality, then put it in the rear. But depending on what purpose your object is used for, you can put the seam wherever you need it to be. And I can show you that real quick. So click your object, and you'll see up here seam painting, and I can just do this, say that's where I want my seam. I need it exactly there. So let's slice it, and there it is. And each white dot is where the printer will start and stop each layer. I have the print running right now with the seam in the corner, and that can cause accuracy issues or kind of like bulging at the seam, really, like, because the print head will just start and stop in the same spot on each layer, and that can sometimes be inaccurate. So I wanted to start this print with a seam in the middle like this, so I can actually accurately measure the cube without having to worry about the seam bulging out in the corner. But I just sent it with the seam in the corner, so I guess we'll see what it's like. So let's go check on the printer real quick, and I'll cut back when the cube is done. Alright, so here is our beautiful 20mm cube, and we are running it right now with the orange PLA again. That's what they sent me to test this printer out, so we're gonna use it. But it's going through its little auto leveling process right now, and I will cut back when it's done. Alright guys, we got the 20 by 20 cube, and let's take a look at it. It looks really smooth. Like, look how smooth that looks, guys. It had a little hiccup right there, a little string there. So that's what I'm talking about. That's the little bulge I'm talking about on the seam. You can see the seam is bulging. That's kind of like on every single 3D printer I've noticed that on. Let's check the height of this cube. And let's check it on this side. That's pretty close. 20.14. 20.15, 14. Now let's check. So that is the z-axis height of the cube right there. Now we're gonna check. Let's see, where's the seam at? The seam is... Actually, I'm kind of impressed with the seam. I can't even find it, actually. But I think... So that's the bottom of the cube right there. You can tell because of the textured PEI build plates texture is on it. So we checked the height of the cube. And it's... On that side... It's 20.1211. On this side, it's pretty spot on. 19.99 millimeter. And rotate the cube and then measure this side as well. 19.98. And let's try another side. That's pretty accurate, guys. 19.99. That's pretty good, guys. So let's move on to the next test. Alright guys, so for the next test, we're going to do the clearance tolerance test found on printables by 3D Maker Noob. And pretty much each of these circles have a different tolerance on the outside edges. This one is 0.1 millimeter, 0.15, 0.2, 0.25, 0.3, and I believe it goes to 0.35 as well. So basically, if these can move back and forth, then it's a successful print. And we're gonna download it. Download the STL right here and save it. And we're just gonna drag and drop just like that. Delete the cube, slice, and let's slice it up. And you'll see. So you'll see different tolerances. See this gap versus this gap here versus all of these different gaps. It's going to test the tolerance of the printer. So we're going to remote print and orange PLA, bed level, resonance, and AI detection on, print while drying on, and start print. And I've really had no problem with just taking the print off and starting another print. There isn't like... It's not like an old school bed slinger where you gotta check it every time you press print. For this printer, guys, I've really had no problem with just removing the print and starting the print. It seems to work pretty well, and it seems to be somewhat reliable so far. Of course, I've only done a handful of prints, so we'll have to do more to test that out. But here is the tolerance test. I will cut back when it's done. Some people wanted to know if the activated charcoal filter works for the smell of PLA, and honestly it works pretty damn good. I cannot smell any PLA at all. Only when I open the printer is when I can start smelling that sweet smell of PLA. But yeah, I think the carbon filter works pretty well, and right now we're printing the tolerance test. So I'll cut back when that's ready. Alright guys, we are done with printing, and let's see, so 0.35, it's good. 0.3, that's really good too, moves around freely. 0.25, that's looking good. 0.2 is a little tighter, but it's still functional. And a 0.15, that's pretty good. You can see it's moving around. That one's good. Now, this is the smallest tolerance, the 0.1. And, okay, wow, it actually works. It's a little stiff, it's a tight tolerance. but just work it around a little bit and it's moving. It's a little stiff there. There we go. That is a successful tolerance test. That's a 0.1 millimeter tolerance right now, moving around freely. Look at that. I think I broke it. Oh, no, I didn't. No, it just goes all around in a circle. But yeah, that's pretty decent, guys. The tolerances are all there. Yeah, the 0.35 is good. 0.3 is good. 0.25. I don't know what happened right there. I don't know what happened there. But it's still working. And the 0.1, that's good, guys. It's working. So that is a successful tolerance test print. It's still stringy, which could have affected it a little bit, but it's still functioning. So yeah, this printer can do 0.1 millimeter circular tolerances, at least. Circular is the key word because these are all circular tolerances. So I would say that passes. We're going to run another test print here. This is the Cali Dragon from MacGyver. And you can see that it's got some overhangs. It's pretty simple little print. It only takes like 30 minutes. We're gonna run this guy and see how it is. So let's go remote print. We're just gonna do the bed leveling and the AI detection. We're not gonna do the resonance compensation right now. Print while drying and start print. The Cali Dragon is done. Let's take a look at it. It's pretty good. Once again, it is stringy. I don't know what's up with this filament, but it likes to be stringy. It looks pretty good, I'd say. The surface quality is good. The little texturing on the back is pretty spot on, no problems there. Yeah, it turned out pretty good. What do you guys think? There we have it, guys. Those are the test prints. Let me know down in the comments what you think, how this printer did. And for a budget Core XY printer at like $5.99 right now, I'd say it did pretty good. I do think that it would benefit from some flow calibration and just some general tuning in the slicer settings and playing around with this filament. Especially the flow calibration, I think that could be dialed in a lot better. One of the big differences between the Bambu Lab X1 Carbon and the Anycubic Kobra S1 is that the X1 Carbon has a micro LiDAR. Bambu Lab has a micro LiDAR, and you can see that every print can have AI detection flow calibration, and I think that makes a big difference. Actually, this printer, it does not do flow calibration at the start of every print because it does not have a LiDAR system or anything like that to actually measure the actual diameter of the extrusions on the build plate. So that's definitely one of the main differences between the X1 carbon and the S1 from Anycubic. I would definitely compare this to the P1S or the P1P. The P1S down here does not have the LiDAR system. I would definitely compare this to the P1S. The X1 carbon does have a little bit more features, which is not bad. I mean, you can always do a manual flow calibration for whatever filament you're using and etc. Something that the Kobra S1 has that the X1 carbon doesn't have, this can go to 320 degrees Celsius on the hot end, and bamboo is not higher than 300 C. And you can see on here that if I go to nozzle temp, I can go to 320 degrees Celsius, which is really hot. Another big plus of the Ace Pro unit here, which is Anycubic's multi-material unit, this is called the AMS, that's called the Ace Pro, but the difference is this is heated, actually drying the filament right now. This one just has passive dehumidifying with the little silica beads. Like there's a little tray in there that you can put little packets of beads. Or this one, which actually you can go in, and I'm drying right now, but I can set the temperature, say like 45 C for 8 hours, and there we go. I'm drying all my filament in the Ace unit, which is a big plus. But if you want to see like this model came out really good, honestly. I have a whole video on that guy, as well as this benchy. I printed the benchy when I did the unboxing. But yeah, I think it did overall. I think it did pretty good, guys. Let me know down in the comments what you think, and let me know what else you would like to see tested on this printer, and let me know more questions or comments or concerns that you have that I can try to address in my next video. So thank you guys so much for watching, and I'll catch you next time.